Hello everyone, welcome to day 18th of March Leetcode challenge. And even before starting today's question, I would like to wish all of you a very happy Holi. I hope you really had a great time in the morning with your friends and family members. Now let's get back to the question. Today's question is remove duplicate letters. Here in this question we are given a string. What we need to do, we need to remove duplicate letters from it so that every character appear only once in it. Also, we need to make sure that we return the smallest lexicographical string that is possible among all the results. So here they have provided us with few examples. I will be talking about these examples as well as the algorithm to go about it by the presentation. So let's get started with it. Leetcode 316, remove duplicate letters. It's a medium level question on Leetcode and I totally feel the same. The question gave us a lot of hints and it's very important to extract those up. So let's walk through each and every statement that was specified in the question so that we get a good hold of the question and the requirement analysis even before jumping onto the algo. Each character present in S must be part of your answer. So this was the first hint that you could infer from the question. You cannot delete any character fully from the string. Any character that is present in the string must be part of your answer string. The frequency of each character should be 1. The question itself says you need to remove duplicate characters. That means the frequency of each character in your answer in the final string should be 1. The third one is lexicographically smallest string should be returned as your answer. Just remember these 3 points and we will try and apply them over various test cases so that we are able to arrive at a solution. So I've taken a slightly different example to what was specified in the question. Here the string is BCA CBE. So how many unique characters are there in this input string? The first one is B, then we have C, then we have A, and then we have E. That means the final string should have all these 4 characters in it. Now we are interested in identifying the lexicographically smallest one, and the frequency of each character again should be 1, which is quite obvious. So let's go step by step. Right now let's start the iteration from the B character, and the string that we have, the answer string that we have is empty. So we'll simply go and add B to it. Let's proceed ahead. Now we see is a C. C happens to be greater than B. That means these are lexicographically sorted in nature, which is in sync with our expectation. So what we are going to do, we'll simply add C to our answer. So we have added B and C together as our answer string. Now let's proceed ahead. Next we see is A. So this time the 8th character happens to be lower in value than my C character. Now I have to make a decision. Either I can append A to my previously computed answer. This is my first option. Or the other option is, since A happens to be lexicographically lower in value than C, I can discard this C. But can I do it always? No, I can only do it if another C exists towards the right of A, which in this case it does exist. Since we see another C towards the right of A, we can simply discard the previous C. What becomes your string? The string becomes BA, because we will be using this C instead of this one when we go for the iteration over here. So far so good. Now again let's reevaluate the string that we have computed so far, which is BA. Again you can see that the previous character is B and the current character is A. As a result of which B happens to be lexicographically larger than A. We are looking out for lexicographically smallest string. Again there are 2 options, either we continue with BA or we can simply discard this B. When can we discard this B? If we are pretty sure that there is another B that will exist towards right of A, which in this case it does exist. So we will simply discard this B again, and the output string will only have A character. We have successfully discarded B and C because both these characters does exist towards the right of A. Now let's continue our iteration. What do we see? We see another C, and this happens to be lexicographically larger than A. So we'll simply go and add it over here. Let's proceed ahead. Next we see is B. B happens to be lexicographically smaller than C. As a result of which we again have to make a decision. But do you see another C towards the right of B? There is no such C, as a result of which we'll have to continue with this C. So the output string becomes ACB. Let's proceed ahead. Next we see is another E, and what is the previous character that was added to the answer? It was B. Since it was B, B happens to be lexicographically lower than E, as a result of which we'll simply go and add it to our answer. So the output string for this particular entry becomes ACBE. I hope I made this algo pretty clear to you. This is how we will go about solving this up. This is not the complete algorithm, but this is in general the approach to go for it. Let's walk through another test case. So here the input string is BCACE. So let's get started again. The first character that we see is B, and the output string was empty, so we simply go and add it to our output string. Next we see is C. C happens to be of greater value than the previous character that was added, so we'll simply go and add C to the output string. Let's proceed ahead. Next we see is A. So we have two options. The previous character that we see is C, and the current character that we see is A. A happens to be of lower value than C. Now shall we delete the C or not? This becomes the question. To answer this question, we have to look out for an instance of C towards right. C does exist towards right, as a result of which we'll simply discard this C and add A to our string. Again comes the same question. We see a B as a previous character. The current character happens to be A. A happens to be lexicographically smaller than B, but this time B would be retained. Why I am saying this? Because there is no B towards the right of A. As a result of which the output string so far becomes BA, and B gets retained, however C gets deleted. Let's proceed ahead. Next we see is C. The previous character is A. A happens to be lower than C. We'll simply go and add it up. Let's proceed ahead. Next we see is E. E happens to be of greater value than the previous character that was added, which is C. We simply go and add it up. The output string becomes BACE, and you can see that all the three conditions that we talked about, each character that is present in S must be part of your answer. The frequency of each character should be 1, and you obviously need to identify the lexicographically smallest one. All of these three properties gets retained in this example as well as this one. Now comes the question, how are we gonna code this up? So what we are gonna do, we will use stack for this purpose, because you can see that we are moving in both directions, towards left as well as right. At each particular index there is a possibility for it. Stacks becomes the best appropriate option for such a use case. Along with this, we will store at what all indexes does each character occur in the last. For example, here we have A, we have B, we have C, we have D, we have E. So what is the index at which A occurs? The last index at which A occurs, it happens to be 2. B occurs, it happens to be 4. C occurs, it happens to be 3. D occurs, it's not there. E occurs at 5. Again, pretty simple and straightforward, no rocket science so far. Now let's start the iteration. What do we see? We see a B. So we simply go and add, we check the topmost element of this stack, it's empty. So we'll simply go and add it to this stack. Let's proceed ahead. Next we see is C. Again we check the topmost element of this stack. What is the topmost element? It's B. B happens to be lexicographically lower than the current character. As a result of it, simply go and add C to it. Let's proceed ahead. Next we see is A, and A happens to be lexicographically smaller than the topmost element of my stack, which happens to be C. So what do we do in such case? We check whether a C occurs towards the right of A or not. So what is the last index at which C occurs? It is 3. And where are we currently? We are currently at 2. So what we should do, we should simply discard this C up. It's not gonna be part of our answer, and again what we will do, we'll revalidate for it for the next topmost element of the stack, which happens to be B in this case. We'll pull it out and we'll check what is the last occurrence of B. In this case it happens to be 4. The current occurrence happens to be 0, as a result of which we can simply discard this B up. So both these elements are gone, and now what we should do, we should simply go and add A to our output stack. Let's proceed ahead. Next we see is a C, and what is the peakmost element? The peakmost element happens to be A. It's lexicographically smaller than the current element. As a result, we'll simply go and add it to the stack. Let's proceed ahead. Next we see is B, and what is the topmost element of the stack? It happens to be C. C happens to be greater than B. As a result of which, we should check what is the last occurrence of B. The last occurrence of C. What is the last occurrence of C? It is 3. 3 is before the current index at which we are iterating, which is 4. As a result of which, we'll simply have to add it to our output string, because there is no occurrence of C towards the right of B. Let's proceed ahead. Next we see is E, and the topmost element happens to be B. As a result of which, this will be lexicographically lower in value than my current character. As a result, we'll simply go and add it to my answer string. What elements are present on my stack? C, A, C, B, E, and we'll simply pop those elements out and build our answer string. The time complexity of this approach is order of n, and it is quite similar to largest area of histogram problem that we have solved plenty of times in the past. The space complexity is also on similar lines, order of n. If you have any doubts, don't worry, everything will be crystal clear in the coding section. So let's shoot for it. Here I've created an n variable which is storing the length of my input string. I have also created a visited array. This is created so as to handle duplication cases. I'll talk about it when we go through the entire section. Next I have created the last index array. The size is 26 and it stores the last index at which each characters occur in my input string. Going ahead, I have created a stack of type integers, and now comes the main algo. From line 13 up till line 28, up till line 24, this becomes the core algorithm of the question. I start iterating one by one using a for loop. I extract my current character. I check if it has been visited in the past or not. If it is already visited, I will simply skip that character up, because we are not interested in adding duplicate elements onto the stack. This test case I didn't explain in the coding section, but it's pretty simple and straightforward. You should never add multiple consecutive characters onto the stack. And I mark this string as visited. Now comes the core algo of my entire question, which is this one. This is similar to largest histogram problem. If my stack is not empty and my current stack character, the topmost character of my stack happens to be greater in value than my current iterating character, which is C, and the last index of my topmost character happens to be greater than I, what do? I simply delete the topmost element from the stack and I mark that character as unvisited. I keep on doing this till the time I'm finding such characters. As soon as I'm done, I simply add that character onto the stack. Once I'm done with this, I have created an answer variable, and this is another interesting case. Here I'm iterating through the stack in the reverse order, starting from the lowest index up till the topmost index. So this is another approach that you should also be aware of. Iterating over the stack in this way will cause it to move from the bottom to the top direction. And once I'm done with this, I simply add it to my answer string and return that result. So let's submit this up. Accepted 90% faster, which is pretty good. The time complexity I've already told is order of n, and the space complexity is again order of n. This brings me to the end of today's session. I hope you enjoyed it. If you did, please don't forget to like, share and subscribe to the channel. Thanks for viewing it. Have a great day ahead and stay tuned for more updates from Coding Decoded. I'll see you tomorrow with another fresh question, but till then, goodbye.